Welcome to our webinar, From Bottlenecks to Breakthroughs in Scaling Secure Research Compute with Activate and the Albert Einstein College of Medicine. My name is Stefan Gary, and as Sophia mentioned, I'm a Senior Solutions Engineer at ParallelWorks, which means I'm taking my physical oceanography research background, where I used to go to sea, make observations at the ocean, work with ocean models, and use autonomous robots for sampling, and also teaching in the US and the UK. I take that whole scientific background and I act as like a science bridge between our users and the development teams on the platform for that produce our product for facilitating high performance computing. So with that, I'll pass it to Shailesh for a self-introduction.
Stefan, it's great to be here with you. Really appreciate this opportunity to talk about what we're doing together with Activate. It's really exciting. And I would just say, my name is Shailesh Shenoy. I'm the Assistant Dean for Information Technology at Albert Einstein College of Medicine. We're a research-intensive medical school here in the Bronx, New York. We have about 1,100 students who are either earning an MD or a PhD in the biomedical sciences, for example, cell biology, biochemistry, neuroscience, or earning a combined MD, PhD. The focus that we have on being able to provide tools for people to do research in an effective way is really kind of at the core of what I think is important to bring value and to give our researchers kind of a competitive advantage. And what are the tools that we can provide them, and how can we provide them in a way that's very easy? And this partnership with ParallelWorks really enables us to do that in a very big way.
Fabulous. Thank you, Shailesh. So the outline for today's talk is to really talk about this synergy between the vision for research computing at Albert Einstein College of Medicine and how that vision matches the ParallelWorks Activate's modular architecture. The two work together in a really beautiful way. And so we're going to talk a little bit about some of the steps toward implementing that vision and how the two have kind of co-evolved. What does that architecture look like? And then we're going to kind of wrap things up with a demonstration showing what the hybrid, which hybrid I mean on-premise and cloud user experience would be like through ParallelWorks Activate as a live demonstration. And then there'll be a Q&A session at the end.
I really like when Stefan talks about, the modular architecture and all the details about how Activate works. It's actually pretty cool. But what I care about is that it works. And what it does for us is it lowers the threshold of complexity for members of our community to be able to leverage the resources that we offer in our compute infrastructure. So right now we have, a compute cluster that's about 100 simultaneous users, 84 compute nodes and growing. We have, at the time this slide was written, 14 GPU nodes with multiple NVIDIA A100s in them, and about 16 petabytes of online storage, billions and billions of files. But the whole idea here, once again, is for this platform to be as flexible as possible, and once again, to lower the complexity so that members of our community, regardless of what discipline they're in, can leverage the platform to meet their needs. And I think, once again, that there was a time when, in order to leverage the resources of HPC, one had to understand command line interface and really understand kind of how it was they had to schedule a job. Now, what we can do is make this significantly easier because there's a graphical user interface and a way that's somewhat more intuitive to be able to leverage these resources, thereby abstracting the complexity out and making this accessible to more people.
Thank you, Shailesh. And on this slide is a very quick animation of what that graphical user interface looks like. But in particular, we often refer to it or think of it as if it were like a control plane or like a single dashboard where all of your compute resources can be managed in a single place. And then it provides sort of like a single gateway, a single control plane, a single place where researchers can go and they can access their resources. It helps focus researchers in what they do, but because it's a single place and everyone's there, it also enables collaboration. And that's a really important part of science and something that we're really excited to be able to support. And one of the key things, I'll use the terms resources, like compute resources, and I'll use the term workflow. The resources are like, that can be the cluster, it's storage, it can be a cloud cluster, cloud storage, and the workflows. So those are, so the resources are like where you run and what you need to use to make the jobs run. The workflows are like what you run. And putting those two together, the where you run and the what you run in the same place can really help accelerate research.
This, Stefan, let me just talk a little bit about this partnership. And I want to, you said something really important, which, I mean, many things that were very important, but one in particular is about how the scientific community is about collaboration. And so how is it that we're able to make our findings and our materials and methods kind of as shareable as possible? That's really kind of what we want to do. So in addition to having persistent login nodes, that are there for folks to be able to access the resources, and the easy GUI that we were talking about, the easy graphical user interface. We want to be able to make sure that we have an environment that's reproducible and an environment that can be very easily shared. And one way to do that, of course, is with containerization. But this is part of what we're thinking about and what our researchers are thinking about is whenever they publish, whenever they make something available to the world, it wasn't that long ago that it took many months for someone else to be able to download all the different code from the repositories, make sure they were compiled to the right version, make sure that everything worked together. And then, just to get, it could take sometimes weeks, if not months, to be able to then just reproduce exactly what was done somewhere else. And that's not really, what we want to do. We want to make this as easy as possible for people to be able to reproduce the work. And that's one of the things that we're able to do also in a way that's more simple here is to containerize these workspaces. And that's part of that architecture that the Activate provides us. And being able to automate those workflows and including the notebooks, I think is really key. This is what is, I think, so important in the scientific community because the days of someone doing work kind of in an isolated way are over, right? I mean, this collaboration is absolutely mandatory for success, not just after publication, but also before publication, and being able to know that, there are many people and that are contributing to any particular project. I don't know, Stefan, if there's anything you wanted to add to that.
Oh, absolutely. Well, it's that reproducibility it's interesting because again, we were talking about synergy, right? And like when Parallel Works started the journey of like deploying to cloud, we use this idea called infrastructure as code,
Yes.
where like the infrastructure doesn't really matter. It's the list of instructions that's used to create the infrastructure that brings it about. And so we do that regularly with the cloud clusters. And then one of the things that we're doing as part of the workflows that run at Albert Einstein is we have environment as code, where the whole compute environment, the whole software stack that a researcher might use as part of a workflow, that is deployed on the fly as a series of steps that exist as code. And so we're kind of moving into this idea where we've taken the idea of infrastructure as code and we've moved it into environment as code. And when you put the two of them together, it really helps to reproduce workflows, right? So it's like containerization, and that like a Docker file will give you the list of instructions to build a software to put it in a container. Environment of code as code is similar, but maybe it works with Conda environments, right? Or SPAC environments, different kinds of, not absolutely everything is conducive to being containerized right there on the spot. And so having that concept of environment as code as a way to do pure containerization or these different kinds of package managers is a really, really powerful way to distribute and deploy.
Absolutely, Stefan. I was just saying it's something that I found very appealing when we first spoke about this many years ago. And it's one can envision how that can be useful and how it can work, but then to actually see it in practice. One of the things that we all know, and I have a good friend of mine who likes to say this all the time, is, to make something really easy is actually very hard. And there's a lot that goes on behind the scenes to make something very, very easy. And I want to kind of applaud what you've put into making, you and your colleagues at Parallel Works to making this work.
Oh, great. Thank you. Yeah, it's been a really amazing team effort. Um, and I don't think I have anything else to say about this particular slide. Shailesh, do you think we could move to the slide talking kind of about the implementation steps and how we got to
Yeah.
the the
And I
the
think
oh
just,
no, I'm sorry. Oh
yeah,
wait, there was
just in
one others.
between here,
Yeah.
one of the things I want to talk about is, what one of the things that I've seen many of my colleagues at other institutions use is a product called Open on Demand, and quite really it's an environment that works and it conceptually is similar to what we achieve with Activate. But one of the things is that it doesn't do everything that Activate does, and I want to differentiate that. And also, although there's so many people involved in making Open on Demand work, there's still quite a bit involved in deploying it. There's quite a bit involved in maintaining it. And while there's a community of people who are involved in doing that, and I have a lot of respect for what they're doing and what they're making available to institutions. A huge advantage for us for working with Parallel Works and with Activate is the fact that it's a fully curated solution that comes with high level professional support. And I think that is really important for our success, to know that we have something that's going to work. And remember, I was talking about achieving simplicity for our clients is very difficult to do behind the scenes. That's really what the effort that goes into Activate represents, is all of that huge work that goes into making the end result simple. And that's what we're subscribing to when we use Activate. And I just want to emphasize, people asking from time to time, why not just use Open on Demand? And Open on Demand is quite good. And there are some limitations in terms of what one can do. But for me, first and foremost, is this idea of working with Parallel Works as a partner that has a fully curated solution.
Oh, thank you, Shailesh. And it's that curation that is supported by the whole concept of environment as code, right? That bullet point at the bottom talking about YAML templates.
Yes.
Those are the YAML is literally the list of steps necessary to create a remote desktop session, or the list of steps necessary to start a Jupyter Lab session running on the head node of a cluster. So. All right. And so I think what the part of the other really important idea with modularization that we discussed earlier is that, as modules are added and stacked together, progress is made, right? As Lego bricks are built upon each other, a city is built. And so, our collaboration has gone through a standing up, a walk, and a run phase where we've progressively developed greater integration and greater capabilities. And so, in particular, we started off installing Activate on the main Slurm cluster, and there it was kind of like a series of standalone virtual machines that were then kind of attaching themselves or connecting to the cluster, if you will. And at that phase, we also went through a process of installing a second version of Parallel Works Activate, but in a secure environment, so that very sensitive medical data could be provisioned. So there were basically two parallel installations, one of which was in a much more secure boundary. But at that stage, it was very much standing up, right? Starting out, putting a copy there, and it was kind of separate. But the where we are now, where we're walking, is where we've taken Activate, and it can now Activate is now working and fully integrated with the new OpenShift cluster um, at the College of Medicine, and it's really exciting because it means that we're integrating new provisioning frameworks like OpenShift into Activate, so that that can be applied, that it basically extends the amount of clusters that can interface with ParallelWorks. And what we're currently working on right now are setting up the personalized user workspaces within Activate to replace the virtual machines that were assigned to each user as login nodes. And so this will help a lot with reducing the IT maintenance requirements on the cluster, as well as helping with scalability and resource efficiency. And this is really great because I just want to say the Einstein cluster is kind of unique in having personalized login nodes. And I really like working with that in that framework. It's a really powerful way to view a cluster. And so integrating that concept even more deeply with Activate, and the fact that we sort of almost by chance had this really great matchup in architecture between personal login nodes and personal workspaces, and being able to really integrate that deeply is really exciting.
So Steph, I mean, this is one of the things that I feel is really critical to our success and also, right? I mean, this once again, in terms of usability and making this accessible. So first, I just want to say in this, crawl stand up phase, the ability for us to run in parallel in both our general purpose compute environment and also within our enclave where we work with protected information, some data that may contain PHI and PII. This is really critical. So the ability for ParallelWorks to implement that and to make that successful is a big key to our success. And then with respect to leveraging OpenShift, this is an initiative that we have basically to be able to leverage native Kubernetes containers within our environment, within our compute environment. And the ability to plug this in to the ParallelWorks basically management is I think been just really, once again, I find enables us to be able to provide that experience that you were talking about, right? And it also lowers the overall administrative tasks involved in running the cluster. And I think that's another key that we want to do is how do we not just make things easier for our community, but easier for us to manage. So, these developments, I think in this maturation, this path is at this trajectory have been really very promising for us.
Oh, absolutely. Well, and it also really fits with the HPC landscape kind of at large, right? Like we were very excited to announce our new Kubernetes provider because there's so much happening in the Kubernetes space for AI, machine learning. And so being able to bring that to a research institution, right, is really powerful. Being able to use that at scale across industry is also really, really exciting. So it's a great synergy for doing that. And that's really where we are at the run phase, right? We're working it hasn't been deployed in production yet, but we are getting to the point where we're setting the framework for that and making that happen, as well as placing sort of more traditional cloud resources side by side with the on-premise resources.
Yeah, that hybrid configuration is really important for success, right? I always envision that we'll have, the best of both in order for us to succeed, just so that we can keep costs manageable, but also take advantage of, the very latest that might exist or that ability to burst. So this is that hybrid capability is very important. I think you've got some details about the
Yep.
architecture itself, Stefan, right?
Exactly. And so I think what we're going to do is we're going to kind of progressively get a little bit more complicated. So we're going to show some architecture diagrams, which are like kind of a nice way to summarize what exactly is happening where. And then we're going to go to a live demo, which will, provide kind of like a test drive experience. And so I wanted to start off with this architecture diagram that shows where we where we are right now at Albert Einstein, and where the integration lies. Right? So there's a legend in the upper right-hand corner that shows the type of connection that's being made. So that might be a technical detail that's not super important to you. That's fine. But basically, what we have on the left side is Parallelworks Activate, and on the right side is the sort of the cluster, if you will, or like the login node and the worker nodes on the cluster. And all of that, you can see there's a big dashed line around everything. All of that is within the Einstein College of Medicine data center. And so Parallelworks Activate has, a front end where there's a user interface, a web page that can be viewed, authentication mechanisms. But really from the user experience, what's really exciting is the user workspace, right? So every user is provisioned their own containerized workspace. You can view it as sort of like a shell in the cloud, or like a place where you can enter commands, right? But it's sitting there as part of the platform. And right now, that containerized workspace has the same, is mounted to the same high performance file system as the cluster. So that means that a user can see their files in their workspace just as they would see their files if they're on the head node or a login node or on a worker node on the cluster. So it provides for very easy access. And what we're really excited about doing is going, when we mentioned the sort of one step further and enabling scaling by basically replacing the login nodes, those personal login nodes, with the containerized user workspace, is this second diagram where the user workspace through Activate is the login node. It is the coordination place that users are launching their jobs and calling up the worker nodes to do their work. And then that way, it actually kind of reduces a little bit of resource usage. But also, because these are containerized workspaces, they can scale up and down really elastically. So, and again, all of this is within the on-premises data center. Right? The next two slides that I wanted to show are kind of two additional, if you will, almost like generalizations, right? When we discussed running, we talked about how to put the on-premise systems side by side with cloud systems, right? So we're going to add a cloud cluster to this, and that's what the following slide is. So here, the idea is to show the Parallelworks Activate platform as is connecting to both two clusters. On the top is a cloud cluster, and on the bottom is an on-premise cluster. And so then this is a system diagram that shows our commercial shared tenancy platform. So so you can see the boxes are separate. So no, the platform itself is in its own network, if you will, its own kind of working space. Whereas the cloud cluster that's attached to it has its own box around it, as does the on-premise system, right? They're kind of separate from each other. Just to note that if we were to implement, when we implement this at Einstein, the on-premise box would be connected to the SaaS box, the platform box. Those two boxes would remain connected. But for the most general case, where a new customer might arrive who may already have resources scattered across multiple data centers and across multiple clouds, it's possible to connect resources that are across disparate sites to one single place.
Which I think is really valuable stuff on it. So could you just, I don't mean to interfere with the workflow, but I can envision that people might be thinking this right now. And if you could just speak really briefly about this. In the case of the cloud cluster, how do data get to the worker nodes? Like, how is that managed?
Sure. So the cloud cluster itself is provisioned within a single virtual private cloud, like a single network, if you will, like you carve out a part of the data center. And so the worker nodes and the head node are all in that one place, and they're connected to each other through high-speed networking fabrics. And it depends from cloud service provider to cloud service provider. They have slightly different, well, dramatically different frameworks. But the point is that we can leverage those really high-speed interconnects to achieve the same kind of performance that you would see on premise, but within a cloud data center. And it requires a little bit of tuning to make it work. But at the end of the day, it's the performance is very comparable. So moving the data around within the cluster is actually pretty easy because it's all within the same space, the same network. What becomes a little bit more challenging is moving from site to site, from across data centers, across clouds, moving on-premise to cloud, that kind of thing. And so there we often use an intermediary a data transfer mechanism, whether it's something like, it could be as simple as copying data to a bucket, a cloud bucket, and then accessing that bucket from a variety of different places, which I can show during the demo.
Yep.
But there are also more sophisticated approaches like various global namespace products and other data managing or data planes, if you will, that can be integrated to facilitate the data transfer. But those bring greater performance, but with additional setup complexity.
Yeah. Fascinating. Thank you.
Sure. Let's see. Before moving to the demo, the last architecture schematic that I wanted to show, which is relevant because we mentioned like a highly secure environment for working with personal information and protected information. So one of the recent, one of the recent recent news for Parallelworks is that we've achieved, or we have this high security platform that is at the IL5 level. And what it does is it basically takes the general commercial offering that we have. So I'll flip back and forth between the slides, and you'll see that I've basically just literally shrunk and moved the Slurm cluster and the platform back and forth with each other.
Mm-hmm.
So what we've done is we've taken the cloud aspects, so that would be the platform and the cloud clusters, and we've wrapped them within a secure cloud environment that has special controls to satisfy the needs of an IL5 environment. And that includes a whole series of things involving networking, authentication, security, logging, monitoring. And so you can view it as sort of like a wall that gets built around it to make it to bring it up to a highly secure environment for certain kinds of workloads. And so this is particularly applicable for government applications. But you can still connect on-premise systems to it and various cloud service providers.
Beautiful.
Let's see here. So I think, with that, we have Shailesh, did you want to speak briefly about some of the applications that are running at AECM?
Well, just once again, if we take a look at the breadth of the type of work in which our researchers are engaged, what are the tools that they need to use and the compatibility of those tool sets with Parallelworks, what can Parallelworks enable? And this is by no means everything, but just a sampling. And I think there are a couple other panels on here if you scroll forward. Yeah. And, this is really, very valuable. Once again, I want to emphasize, what this does to simplify the engagement that our community has with the compute resources here. And, I'm really excited about what this has enabled.
Fabulous. Thank you. So I think what we'll do now is we have time for a live demonstration. This will last about 20 minutes or so. And then after that, we'll have a series of Q&A. And I hope very much to touch on this and bring to life a lot of the things that have been discussed so far during this presentation. And so I'm going to work through this list of concepts. We're going to talk about self-service access to on-premise clusters, a live demonstration of that user workspace, where you have like your own personalized workspace. Then we'll run a couple workflows, including the interactive sessions or these graphical connections to clusters. So like things like Jupyter Lab or remote desktops, as well as a couple quote unquote classical number crunching jobs. And then we can talk a little bit about the cloud resources and how the cloud resources are brought into the user experience. And that's all very much, that left side, that left column is very much like the user experience, or like, the researcher experience, if you will. And then I wanted to break it up into two parts, where the second part of the demo, we'll talk a little bit about the management or the organizational experience for what are some of the best practices that we've developed for managing large teams of high performance computing users. Things like how we implement zero trust practices, how we can control costs, and then in particular, and then as well, some details on environment as code, as we discussed earlier, and creating custom workflows. So with that, I'm going to exit the slides and jump into a browser tab. Is this, Shailesh, is this visible to you?
Yes. Yes.
Perfect. Great. Thank you very much. And feel free, Shailesh, if there's anything in particular that you want to interject about, feel free to jump in.
Absolutely, we'll do that.
I wanted to note for everyone here that I changed the branding on our platform. So the URL that I've gone to is activate.parallel.works. This is our general commercial version of the platform. I'm not running this demonstration on the Albert Einstein College of Medicine resources, partly because I don't want to accidentally show any private information, right? So that's why I'm running the demo in the commercial side on an account that I created especially for this workshop. But what I can do is I can change the branding, right, to make it kind of look like what the user experience would be like. And that's a fun customization feature that we've recently added. But really what I want to guide everyone to at first is this idea of self-service connecting to a cluster. There's a lot happening here, a lot of buttons and things. And really what I want to focus on is this cluster here with the on-off button called on-prem. This is how we connect to an on-premise environment. So by pressing this on-off button, a pop-up will appear, and it'll go through the process of making an SSH connection to another cluster. And this is nearly the same as what would happen at Einstein. It's a little bit different for various technical reasons. But the key thing here is that we scrolled through the connection, a variety of different things happened. Users can see how their credentials are being used. And if there are things like multi-factor authentication, like multiple steps that need to be made to authenticate to get to the cluster, it's possible to include them here. But I didn't include that as part of the demo just to make things smooth. But if an MFA prompt is needed, this process can pause, wait for that prompt, and then continue later. So with that, the cluster is on, a nice friendly green dot. And I have my username on that cluster and an IP address. In the background, I just want to show briefly how this is configured. I can adjust things like what my username would be, what the IP address would be, and then here I'm just using SSH keys. However, I want to note that with certain clusters, more sophisticated authentication mechanisms may be necessary. So things like proxy certificates that are going through single sign-on and so on. And that is entirely possible. So I'll go back to the list. So I've connected to a cluster. How do I use it, right? So a lot of folks may be familiar with going on the command line. And so we provide a very easy way to get right to the command line on a cluster by clicking on your username for this cluster, and a terminal pops up from the bottom. There we go. And I can ask who am I on this cluster, which SF Gary, which matches my username in the configuration as well as what's there. I can run various other commands like sinfo to indeed show that this is a Slurm cluster, and there's a variety of nodes and partitions that I can use on this cluster if I need to. However, this can be a bit, we want to provide for easier user access, right? So moving beyond just moving beyond the command line, right? And so when I popped up this terminal, there was actually two things that happened. Where is it? Here we go. There's also this other prompt that I have, which is my Parallelworks user container. And so here I may have a different username. In this case, it's pwdemo.stefan. And I have in my personal workspace, I have some clusters, some jobs, some storage, and some workflows, right? Again, this is very abstract, but this is the command line access to my personal working space. If I want to get one step further down the line in terms of a graphical view of that personal workspace, I can go to our editor tab, which will start a full-on integrated development environment inside that personalized workspace. So I'll make this bottom terminal go away and open up the editor. And so in the editor, I'll just close this terminal. This editor has the same clusters, jobs, storage, and workflows that I was able to see on the command line. But now I can browse them interactively or visually, and I can see like maybe results of jobs that I've run in the past. And I can also, if I want to, I can open up I can open files and view them. So for example, here's an example file that I can just open up, and I can start editing inside my tree of files. So it provides for a very nice, quick way to browse the files that are available in my personal workspace. But there's also a bonus, is that it's not just the files in my workspace. This clusters folder allows me to mount the home directory, or actually other directories, from any cluster that I have connected to my account. So when I display this, I'll make these smaller just so that it lists. Right now I have two clusters connected to my account. There's the on-premise cluster that I connected to just at the early part of this demo. And that's listed here with on-prem/home. I also happen to have a cloud cluster that's up and running, and we'll talk about that cloud cluster in just a minute. That's also connected to this account, and its files are available to me through this interface. So I can open up and see I've got a variety of files on my cloud cluster, and I can open up again and I can see I've got a variety of files on my on-premise cluster. And you can actually drag and drop between these two. So if you open up a Jupyter Notebook in one, you want to move it to the other, move files back and forth, it's possible. Although it's not going to be as high performant as some other data systems. So really, this is good for small files, for dragging and dropping between these two things. Okay. So that's kind of an important, really what I wanted to discuss in terms of, and try to provide a kind of a real world example of what I mean by a personalized user workspace, right? This is a place where I have all my files in Activate, and not only is it just the files I have on Activate, but it's also the files I have on my clusters. Okay. So now that so basically up till now, we've really just talked about access, right? Connect to a cluster, look at its files. So let's talk a little bit about workflows. So I'll go back to my home page, and workflows are really about taking things to scale through automation, right? A workflow is just a series of automated steps. And those steps can be the automated steps to run a large simulation like pre-processing, simulation, post-processing. Those steps can also be the steps necessary to start a graphical connection to a cluster. So for example, I have my on-prem cluster is running here, and I'm going to connect a Jupyter Lab. I want to start Jupyter Lab on it. So I'm going to go to my workflows pane and select a workflow, and it comes up with the workflow launch page. And basically behind this page is the list of automated steps that is necessary to start Jupyter Lab on a cluster. And I can show you, a little bit deeper how those steps are programmed and managed. But for most users, they don't want to see that. They just want Jupyter Lab on the head node of the cluster. And so that's what we can do. I just have to select between whatever clusters I have running. So I'll pick on-prem. I can choose between launching a job on the controller node or the head node or on one of the partitions. But for speed, I'm going to use the controller. And then all I have to do, I mean, there's additional settings that are hidden below for Jupyter and various customizations. But I'll skip that for now. And really all I have to do is hit execute. And then this workflow is going to go through the steps necessary to start up Jupyter Lab on my on-premise cluster. And while we wait, we provide a handy workflow progress viewer. So I'll click on this link, which will take me to what we call a noodle diagram of the various steps that are happening as the Jupyter Lab instance is starting on the head node of this cluster. So there's we break it up into kind of main jobs, and then within each job there's multiple steps. And at each point you can grab the logs for each step to inspect what's going on and check your progress. And so and you can also visualize in real time how this is how the process is moving through here. Okay. For folks who are watching very closely, you'll notice there's some Kubernetes jobs that are listed here. And that's because this workflow can run on either a Kubernetes cluster or on a Slurm cluster, and just has to be selected by the user. All right, so let's go to the home page to see, this is the main dashboard. And so how do we connect to this running Jupyter Lab instance? So if I scroll down a little bit, you'll see that I have a list of sessions that are running. And I'm going to decrease my screen zoom just a little bit so we can see the whole there. So I have two sessions already running on the cloud cluster. It's called GCE. It happens to be a Google cluster, but we also provide access to AWS and Azure clusters. So that I know where these sessions are running. And then this last session here is the Jupyter Lab session I just launched for my on-premise cluster. And I can tell because it's got that little on-prem tag here. And if I click on the link, here I am. Jupyter is going to appear for me. And I can start working right away. So I can click on a notebook and start writing some code. For example, where am I here? And maybe a little bit of Python code. There we go. And this is all very wonderful, except that, in the real world, we'd be running machine learning or something far more interesting. But I can save this notebook. as say demo.ipymb. It appears in my Jupyter file browser, but if I want to, I can go and view that on my workspace file browser, right? So say I want to transfer it from this on-premise cluster to a cloud cluster. And so here, if I go to editor, which is, again, the browser for my whole workspace. And I'll do a little bit of cleanup here. On my on-premise cluster, I can see the demo.ipy notebook. And I can literally just drag and drop it into my Google Cloud cluster. And it appears on the Google Cloud cluster. And if I go to home and now connect to a different Jupyter session, I'll see that notebook ready for use. It must be buried inside one of those files. Which one did I put it in? Okay, well, I've lost track of it, but it's somewhere in there. And in the interest of time, I'm going to move on. But it would, if I must have dragged it into the wrong directory, and then but the same notebook would pop up, right? I guess one of the key things that I wanted to, so this is very much what the user experience is like, right? And one of Shailesh's questions earlier was, if your files are bigger and you need to use, like, how do you do like big data transfer? That's really what I want to get to, because that is also a really nice demonstration of how we apply zero trust in organizational policies. So on the platform, we also have a whole section associated with storage. And there's many storage options here. I'm not going to go through all of them, but basically you can view them as a spectrum of slow but less expensive storage toward very fast but very, very expensive storage. And buckets are nice because they're slow, but they're not very expensive. And I've already configured a bucket. ParallelWorks allows you to add storage and configure storage just like you would add a cloud cluster to your account. And you can turn it on or off. So if I wanted to destroy my bucket, I could. It gives you control over where your data is. But the key point is that this bucket provides, I'll go back to the home page so that you can also see that there's like a buckets tab where you can kind of see a dashboard of where your buckets are. The beautiful thing is that there's a couple different ways to access this bucket. And one of these ways are short-term access credentials. So with one click, you can get the information that you need to copy and paste to pretty much any computer what is basically the passcode necessary to access this bucket. And you could take it to your laptop, you could take it to another cluster, and we also provide examples for how to use those credentials to access the contents in that bucket. But the beautiful thing is that this username, effectively username and password, is limited to just the bucket, and it's only valid for 12 hours. So this is the important concept when it comes to zero trust, because it's about creating credentials that are only valid for a short period of time to do very specific things.
It's a really powerful point, Stefan. I want to emphasize that. We're always keeping an eye on being able to protect our assets and, knowing that there's a focus here on what can we do to keep these, these type of buckets, for example, very helpful because they give us that place that we can access data from anywhere, but also that introduces a new risk, right? That's a new potential attack surface. So anything that we can do to help insulate us from that attack, using methods like you described right here, that's so important.
Absolutely. And, there's some organizational controls that we have in place as well. So for example, we can allow organizations can create users. Here's a list of sample users for this organization, but users are organized into groups, And groups, this is very important, have different levels of permission, right? So you can choose which groups have access to which keys, which groups have access to which resources. And also you can set the allocation. So this particular group can use up to $100 of computing. And so we set the allocations and cost controls based on the groups. And as well, from an organizational perspective, organizations will enter their cloud key one time. It gets stored in a vault. And then every operation, whether it's creating a bucket, creating a cloud cluster, or whatever, the short-term credentials are issued from that one source key in the vault.
Yep.
And so that way we always retain short-term credentials, and we never give users general access to the cloud console, which can be very confusing for a lot of users.
Yeah, it's true. Well, this plus the cost controls I found very interesting as well for people to see.
Absolutely, yeah. We have a cost control dashboard. So this is the group. This is the dashboard that for this particular compute group. You can see we haven't spent very much in our demo today.
Yeah.
But and it's taking a little bit of a while to render because it's very generalized, right? And I've not used it for a long period of time, but you can see spend over time, where, like, for groups that have much more usage, right? You'll see, like, spend over time. Are you hitting a threshold? And compute resources, depending on organizational policies, can be shut down or paused based on how close you are to particular thresholds. So maybe at 80% you get a warning, 90% there's a pause, at 99% things get destroyed, right? So, but organizations can set that level.
Yeah. Excellent.
So I think that's pretty much all we have time for the demo, and I'd really love to make time for questions.
What are some best practices for giving researchers access to secure computing resources without overwhelming IT or compromising compliance?
Great question. And I think one of the things that we could do at any institution is to leverage basically provisioning using an automated method, right? So for example, one thing we could do from a infrastructure perspective, we happen to use Active Directory. Everything here uses, POSIX compatible permissions as well. So what'll happen is for people to be provisioned in a particular environment, their account has to just basically go into a particular Active Directory group, which then propagates into an LDAP group. And then it makes the whole thing super simple. And so if there's any particular review process that's necessary for regulatory reasons, for example, an internal review board analysis or anything, it's a matter of putting someone in. And then, of course, when they leave the institution, their account automatically gets disabled, so they lose access to the system. That's what I found. Basically, if all the wiring is in place and everything is there, then provisioning just becomes putting someone's account in that AD group.
Absolutely. And then Activate follows that pattern downstream, right? Where the authentication to the portal, the Activate portal, is through the same AD group.